Okay, example 5 tells us to evaluate this equation from 0 to 5, interpreting in terms of area. And this is going to be something that happens in your homework. It's a pretty typical structure, but it just, maybe you haven't seen it much. But let me just do a little simplification here and you can see what it becomes. So I have a square root in this problem, and typically when you have square roots in problems, it's better not to have a square root in the problem. So if I move the 3 over, I'm going to get y minus 3 is equal to the square root of 25 minus x. If I then square both sides, with the intention of getting rid of the square root, the square root of 25 minus x squared is going to be 25 minus x squared. If I just keep y minus 3 squared as it is for right now, and you'll see why in a moment. Okay, so I'm here, and then I'm going to slide the x squared over to the left so everything's on one side equal to the constant. So x squared, in fact I'm going to call it x minus 0 squared plus y minus 3 squared is equal to 25. So that's what we're looking at, and what I'm looking at here, if you recognize from geotrig, and I think even towards the end of Algebra 2 we dealt with this is a circle equation. An x expression squared plus a y expression squared equals a number. And that number is the perfect square, or the square of the radius. And if I was just to graph this all by itself, 1, 2, 3 spaces up, circle of radius 5, 1, 2, 3, 4, 5 to the right, 1, 2, 3, 4, 5 up, 5 to the left, 5 down if I wanted to do the whole circle. Now, what I want to get across to you, and what I want to make sure that you understand about this, the interval's from 0 to 5. So everything left of 0 doesn't count. So where typically you go up and right and left and down, everything over here is out because we're starting at 0 going to 5. Okay, so that takes care of that part. If we consider this part over here, theoretically I could be going down 5 spaces also, let's say here. Let's just pretend I do that. And I draw my circle like so. Alright, the reason we don't get the whole circle, but instead we actually are going to stop right here, is because of how this is written. This says 3 plus the square root of 25 minus x squared. Alright, let's just pick a number for x, just to pick a number. Let's say I pick 1. It's going to be 3 plus the square root of 24. It's not 3 plus the 24 and 3 minus the square root of 24. We're only taking the positive square root here, not the positive and negative square root. The negative square root is what we get the bottom part of this circle. So when you get a circle equation, just be ready to either do the top half for a plus or the bottom half for a minus, and then the interval is going to either get you all of it or a quarter of it. So the plus the square root of 25 minus x squared just gets me the top half. And what I'm looking at then, if I were to draw down to the x-axis again, beginning of interval, end of interval, go from the graph to the x-axis, from the graph to the x-axis. And again, what you want to be able to do here is to establish different geometric figures within this picture that allow us to find areas. If I were to draw this segment right across here, what you'll notice is we have a rectangle right here, and stopping at the x-axis, but that's a rectangle. And then up here is a quarter circle. Our goal, if we're going to interpret in terms of area, is to get shapes that have actual geometric formulas that allow us to find areas. So if I find the area of the rectangle, the area of the quarter circle, add those areas together, I'm going to be able to find the overall answer to this problem. To actually do this specific integral for real, using a technique that we're going to learn in chapter 5.3, which is going to be pretty nice when you get it, but to be able to do this, it involves an inverse tangent would be an answer to that, and that's something we don't cover this class. That would be a Calculus 2 integral. But if we get it down to basic geometry, 1, 2, 3, 4, 5 across, 1, 2, 3 up, that's a 5 by 3 rectangle. So the area of the rectangle is going to be 5 times 3, which is 15 square units. Looking at the quarter circle, we have a radius of 5. and it's 1/4 of a circle. So the area of the quarter circle, I'm going to put 1/4 circle, is going to be pi times the radius squared. And we're going to multiply that area, the area of the whole circle, times 1/4, how much of the circle we actually have. And if I add those two things together, the exact answer to this problem, so the integral from 0 to 5 of 3 plus the square root of 25 minus x squared dx is equal to 15 plus 25 pi over 4. That's the exact answer. That's to the billionth decimal place. Square units. And again, with evaluating integrals, if you just want to get me the answer, you don't have to put square units on it. If I wanted to approximate it, I'd use the pi button. 15 plus 25 pi divided by 4. My calculator says it's 34.63. Okay. Either one of those answers, unless they specifically say find the exact answer, I'm fine with both of them. I personally typically go with the approximate answer myself when I'm doing this, but again, the exact answer is not that hard to find. Main idea here is if you see number plus a square root expression, expect it to have either a quarter circle. If it said from -5 to 5, then it would have been the entire half circle. If you just imagine going that way. So we'd have gotten this whole rectangle here, base of 10, height of 3, had a half a circle instead of a quarter, so that'd be 1/2. So, you know, that's how they're going to change it up. They don't usually put the -1, they usually put the +1. So we usually get the top, either half of the circle, or if we're only going from 0 to the end of the radius, then we're only looking at a quarter of the circle. That's how to handle those. I think there's 2 in the homework like that. So just be looking for it, be ready for it, and it should work similarly to this one.